Hello class, this is Mr. Lehman. I want to do a different type of stoichiometry problem with you today. In the last tutorial, we went from mass of known into moles of unknown, back into mass of the unknown. A slight variation of this problem is, well, what happens if the question gives you this many particles? Now, if you know how many particles you're starting out with, this is a conversion that we learned how to do back in Unit 7. The number of particles divided by how many particles there are per mole will allow you to convert into moles. Alright, so if we start with the number of particles and not the mass, we're going to divide by 1, multiply by 1 over 6.02 times 10 to the 23rd, which is the same as dividing by 6.02 times 10 to the 23rd. That will give us moles of known. From there, we do the same step. The heart of every stoichiometry problem is to go from moles of known into moles of unknown, and we do that by multiplying by the mole ratio, unknown over known. And then if the question asks for you to solve for mass, we could multiply by the molar mass. But in the problems that we're going to do today, I'm going to ask you to solve for how many particles we can make. How many particles of product we can make. And so we got to multiply by 6.02 times 10 to the 23rd to convert back into particles. Alright, so let's go ahead and get started. So let's use that same reaction that we started with yesterday. And we're going to look at the silver nitrate and copper reaction. We established in our last tutorial that 2 silver nitrates, which are aqueous, will react with 1 mole of copper, which is a solid metal. We saw the coiled wire to make copper nitrate, which is a blue liquid, is still aqueous, plus silver metal, which is solid. And we established that there's 2 moles of this reacting with 1 mole of this to make 1 mole of this and 2 moles of this. So let's say we have 2.10 times 10 to the 23rd formula units. Remember, when it's an ionic compound of salt, instead of saying molecules or instead of saying atoms, salts are found in crystals, and the simplest unit is called a formula unit. They're not individual molecules. So if we have 2.10 times 10 to the 23rd formula units of silver nitrate reacting with excess copper, then how many formula units? And actually, let's go ahead. Let's do like we did in the lab. Let's figure out how many atoms of silver metal we can make. So that way we're not multiplying this molar mass again, which can take some time. Alright, so we take what we know and label it. We take what we don't know, label it, so we're clear of what the problem is asking us to do. And we're going to take the 2.10 times 10 to the 23rd formula units of AgNO3. Lots to label here. Put that over 1. And then we're going to convert into moles. So 1 mole of silver nitrate will be made up of 6.02 times 10 to the 23rd formula units. Alright, so those units will cancel. I didn't write the units for that down here because I'm going to run out of room. The next step is to multiply by the mole ratio. Unknown, so 2 moles of silver can be made from 2 moles of silver nitrate. That makes sense. We need 1 of these to make 1 of these. Oops. And then the last step is to not multiply by the molar mass, but we're going to multiply by how many atoms of silver there are in 1 mole of silver. And so if you look at the setup of this problem, we have 6.02 on the bottom dividing with 6.02 here in the top. And so 6.02 divided by 6.02, there's this 1, and 1 just basically cancels out. And so we take 2.10 times 10 to the 23rd formula units times a 2-to-2 ratio, which is a 1-to-1 ratio. So we're just basically timesing this by 1. We're going to see that our answer is the same. Our answer is 2.10 times 10 to the 23rd atoms of silver. So that's pretty easy. So as particles to particles, the 6.02s are going to cancel out, and really you're just taking how many atoms, how many particles, how many formula units, how many molecules you're starting with, and times them by the ratio. Alright, let's do one other type of problem. Let's sort of mix the two types of problems together. Let's do, let's see, something that's a little bit more complicated. Let's do aluminum metal plus oxygen can synthesize to make aluminum oxide. So that we're working with some different ratios. So we need 2 here, we need 3 here, and a 4 here. So let's say, once again, we have excess oxygen, and let's say we have 5.01 times 10 to the 23rd atoms of aluminum that are reacting with the oxygen. We want to figure out how many grams of aluminum oxide we can make. Alright, so if we look at our pathway here, first step, we're going to do a number of particles, convert into moles by dividing by 6.02 times 10 to the 23rd. We're then going to multiply by our molar ratio, unknown over known, to convert into moles of unknown, which is aluminum oxide. Then the last step asks us to solve for mass, and so we're going to follow the top pathway. So we want to go back into mass, not into number of particles, and we got to multiply by the molar mass of our unknown aluminum oxide to do that. So let's set it up. We're going to take what we know, 5.01 times 10 to the 23rd aluminum atoms, put it over 1. We need to convert into moles. We do that by dividing by Avogadro's number. 1 mole is made up of this many atoms. Canceling out of atoms, converting into moles, multiply by the ratio. Unknown, there's 2 moles of unknown for every 4 moles of our known, so 2 to 4. And then we want to multiply by the molar mass, so 1 mole of aluminum oxide is 2 aluminums plus 3 oxygens. So aluminum is 26.98. I'm calculating this right now, is 53.96 plus 3 times 16 for the 3 oxygens, which is 48. So 53.96 plus 48 is equal to 101.96 grams of aluminum oxide. Alright, so moles of aluminum cancel, moles of aluminum oxide cancel. So let's go ahead and calculate 5.01 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. And we're going to multiply that by 2. We're going to divide that by 4. And then we're going to multiply that by 101.96. And we got to round to 3 sig figs since this only has 3 sig figs. So our answer would be 42.4 grams of aluminum oxide produced. Alright, so I hope this helps. Alright, have a good day.